Hi, welcome back to the breadboard, and in the style of Ave, we're actually in the wife's sewing room today. My benches in the lab are a little bit full, and I know that this in here is going to take up a bit of space while we go through building it. So what do I have? I have a 3D printer kit sent to me by GearBest. I reached out to them because I'm doing a series on building 3D printers and wanted to get a kit that I could show the quality and building of as well as part of that series. So here it is. They kindly sent me one. It's completely disassembled, unlike things like the CR10 where you have about 6 screws and you're pretty much done. This one is completely disassembled with a few exceptions. So let's get closer to the box and have a look. And if you're wondering, this really is the wife's sewing room. She's out right now, so she doesn't know I'm using it. So we better be quick. Let's get to the box, see what's inside. Okay, so I already opened it because I wanted to have a quick check. There was some damage done to the box, but suffice to say, big ding out of the corner and a few other little marks and things. But I have not pulled it apart and inspected anything so far. So what do we have? Let's just open the box up. As you can see, it's not too big a box, but it weighs a lot. Foam packaging, we can ditch that. Okay, right up top we have X5S wires connection. So what we have here is a Tron XY, or Tronxy as a lot of people call it, 3D printer. It is the X5S version, which is the high resolution model, and it has a print bed of 330 by 330 by 400 in the Z-axis, so that's quite a big print area. This is supposed to be a complete kit, so we will have a look at the quality of some of the parts and how easy it is to put together. I will try to use only the bits that are in the kit to start with, and if there are necessary extras that we need to add after that, we'll do that in another video. The purpose here is to have a look at this and get it built initially. So first piece of paper on the top here is just a bit about wiring the extruder and the hotbed. So let's just put that aside. We'll clear this box out as we go. So there's 2 trays in here. Top one looks like it has inserts for the extrusions. This is built using 2020 V-rail extrusions, I believe. So here, these are just to give it some pretty blue color, cosmetic only. We have a little bit of filament. That's about all that came with it. We have PTFE tubing, probably for the hot end, on the top here. It looks like we have the hot end, the heat bed, pre-wired to a cable chain with a thermistor held on with what looks like painter's tape. That might have to be changed, but we'll go with it. We have a screw loose. Not sure where that goes to, but we'll keep a hold of it just in case. Let's just drop that back in there for now. On top of here we also have power supply with an acrylic end plate on it. So I think I've just found where that third screw might be going. There's a screw missing here. There's a hole for it, but on this side you've got 2 screws. On this side there actually isn't a hole for it to go into, or if it is, it's misaligned. 110 volt 220 volt power supply, 12 volt output, 30 amps, so plenty of power in here. And we have a switch on the side to set 220 or 110 volts. It looks like it's a little bit of an angle, and it's also currently set to 220 volts, so we'll need to change that before we power this thing up. It's got a nice IC connector for the mains cable on the end with an on-off switch. I'm going to open this up just to make sure things like the ground is connected and stuff like that. I've never heard of anybody else saying that there's been a problem, but I do want to make sure that it's safe before we start using this. So we've got the power supply, USB cable, a bunch of cables for probably the stepper motors and sensors and things like that. Short flat ribbon cables for the display, I would assume. A couple of limit switches, probably for the X and Z. We have a USB stick. I'm assuming there's going to be some demo prints and potentially maybe manual and things like that, because there is no manual in the box here. We have a mains power cable, and we have a small piece of acrylic. Some of this acrylic's got a few scratches on. There's not a lot of care. I've noticed in some of the other videos that people have done, these have all been covered in the manufacturing tape. It's like a paper that covers the acrylic when they're, when it's made, and most times that gets left on when they're being cut out and things like that. In this case, it seems to be removed, so that's probably how it's managed to get scratched up or something. We've got a proper Canadian USA style mains adapter with ground. It's not a very long one, but it's probably long enough. We have a kit of parts, so we've got a pair of side cutters, a crosshead screwdriver, a small flathead, a couple of bulldog clips, Allen wrenches, big bolt probably for holding a filament spool, and a small wrench. So that looks like they've provided the complete toolkit to build this thing together, which is kind of nice. That's everything that's on the top layer. So let's pull that off and put it aside there for a second. And we're on to the bottom layer now. Let's just pull this out and get rid of the cardboard box. It'll be easier. This one's pretty heavy. All right, let me just adjust the camera a little bit. Okay, so lots of aluminum extrusions. Let's start from the back here and work forward. Large aluminum, or for those in Europe, aluminium plate. I think this one is for one of the Z brackets to go up and down. It looks like it's got two holes for linear bearings and one for a threaded insert for the lead screw. We have a pack of extrusions, or sorry, a number of extrusions. These are, this particular one is a 2040. These are V-rail, so if you're familiar with open builds, you'll be familiar with these. These are black anodized. It looks like they've got a lot of the metal shavings still on the plastic that's covering these. So before we assemble, I'll take these outside and blow them off with an air line, just so we don't have little bits of metal floating around. So these are probably in a number of different lengths. So we've got, let's just pull these out. 1, 2, 3, being careful not to get bits everywhere. 4 of whatever length this is. Actually, it's useful working on the wife's cutting board because I can measure things. It's got cuts on it. So that's 21 inches, just under 21 inches long, those 4. Of course, this would be a metric kit, not an imperial kit. Here you have another metal bracket for the other side of the heated bed for the Z-axis mechanics. Okay, let's start near me. Boatload of belts and spiral wrap, oops, and a load of cable ties as well. A little bag full of cable ties. So we've got the belt here. It's probably going to have to be somewhere close to 5 meters worth to get this done. It's broken into 2. I'm not sure what this is made of. It looks like it might have some metal inside it. But we've got 2 strips. Obviously, I don't know if you're familiar with Core XY 3D printers, but the head moves in the X and the Y direction. And there is no such thing as an X and Y motor, really. The 2 motors that drive the head actually have to work together to move the head in a straight line. When both of them move, the head is either going in the X direction or the Y direction, and when they move individually, it's going in a 40-degree angle So it's a little different than a standard Cartesian Prusa i3 or something like that, where there's one motor for each axis. This one, they have to work in concert. So there's some belts, spiral wrap for, I guess, wrapping around the wires once you put it together, the cable ties. Looks like we have the heated hot end here, again already fed onto a cable tray, cable chain, which is nice, saves a lot of hassle, probably easier manufacturing, less customer complaints. These are all V-rails, and these have got what probably are, I don't know if they're Delrin or some other material for the wheels, but they do not have eccentric nuts for adjustment. So let's hope that they've got their tolerances correct. As you can see here, we've got a micro switch for the limit, which is probably the X. Yeah, I guess it goes that way. So it's going to be the X limit switch as it moves across to the side. It's designed for Bowden tube, so we've got the connection for the Bowden up here, on here. We'll have a closer look at this as we start building them together, of course. And we've got a fan for the hot end and a fan for cooling. The cooling is only coming out on one side, so from what I've seen on some existing videos, that's a popular update to get the cooling for the part to go around the hot end to get better cooling. But we'll test this as it is before we start thinking about any upgrades to that. So what else have we got here? Right side carriage for the top, and with a couple of pulleys. These are not full pulleys. It looks like they've got some bearings inside for the belts, and then some solid washers to space things out a little bit. Again, made with acrylic, the plates, so lightweight but still pretty robust. The paper's still on in this case, so that's good. Let's just put these down. So we've got the left and right versions for these, all pre-assembled. We have the left and right pulleys that are, I think, probably static ones for the corners of the top of the bed. So that's those, again, all pre-assembled. Bag full of nuts, bolts, T-slot nuts, etc. Now, the nice thing that I've seen a lot of manufacturers doing now is they're actually using the T-slot nuts that you can put in without having to slide them into the ends of the T-slots. There's nothing worse, and I found this through experience when I was building my first CNC router, which is on one of my other videos, of getting everything assembled and then suddenly realizing that you're one T-slot short of what you needed, and you got to take it all apart again just to get that extra T-slot in. It's a bit of a pain in the ass. The T-slot nuts that are here, you can actually insert them into the T-slots from the side, not the ends, and then as you tighten up the screw, they rotate and lock into place, which is really cool. Anyway, bag of nuts, bolts, etc. We have two stepper motors. I'm not sure whether these are 200 steps per revolution or whether they're 400 steps per revolution. You might be able to look up the part number and check that later. And they've got the flex couplings. So these are going to be for the Z-axis. One's going to mount on each side of the printer, and it's going to drive the Z-axis through this coupling to the lead screw, and then the other one at the ends of here, we're going to have the two linear rails with the linear bearings on them to provide that extra guide for the platform. So we have two of those. Let's just pull those out here. Actually, we'll leave them in just to keep them out of the way until we need them. It's probably a bit easier to do that. We have the controller board. So this is a, I'm not sure what processor's on here. Let's just get this open. We can have a look. So it's got a label over the processor, but hey, you know, labels are for removing. So we've got the 4-stepper outputs. We've got the X motor, the Y motor, the Z motor, a second Z motor, and the E for the extruder. We have temperature sense inputs, and we have E-stop limit inputs. 2 connections for the LCD display, and we have power in, and we have hot end and heated bed out. We also have 2 connections for fans, a USB port and a micro SD card slot. A little button here for probably for reset. And all the components have got heat sinks on them with some probably heat sink goop compound, a little bit flexible. So I'm not going to be able to pull these off easily without risking damaging the chips underneath to see what they are. 2 MOSFETs here for obviously driving the extruder and the heated bed. These ones, I'm not sure which steppers drivers they're going to be using. We'll see if we can look that up and find out. Anyway, that's the controller board. Nice. Doesn't look like there's any bodge marks on it or anything like that. We have a, I think, cover for the controller with a little fan on. Fans are pre-mounted. Looks like it fits exactly, yeah, over the mounting holes for the board. Not sure which way around it goes yet, but we'll find that out soon enough, I'm sure. We have a pre-assembled extruder, all metal. Well, the bracket to mount it to the frame is plexiglass, but the 1, 2, 3, 4, 5, 6, these are 6-pin stepper motors by the look of it. I think all of them are. Yep, they are. So we've got an all metal extruder with a brass pinch wheel, tooth pinch wheel. It's not a cob. Sorry, it's not a I can't remember the name of it right now. Anyway, grooved bearing for guiding the filament, and the brass hub wheel for driving it through and gripping the filament, with the fittings for the PTFE tubing on the top, and of course the filament's going to come out come in the bottom, come out, go straight to the hot end. So there's the extruder. We've got a bag with metalwork, so these look like the linear bearings in here, and the ends for holding the smooth rod steel guide rails into the frame. We have another bag with looks like the feet and the brass Z-axis threaded nuts for the lead screws. So these aren't anti-backslash, but because they are working with gravity, there isn't really an issue with backlash on that. That's good. We've got 2 more motors. One will be for the X. It's got the gears already on here, and it's their teeth pulleys look like they're probably 20 tooth or something like that. 2 grub screws for gripping onto the steppers, and the steppers have a flat mark to help with getting the a good tight fit so they don't slip. 1, 2 of these. Working our way around here. Another bag full of plastic parts. Looks like mounts for the X and Y. Well, they call it X and Y, but they're not really. Stepper motor, probably limit switches, and miscellaneous other parts. We'll figure those out as we assemble. We have what looks like the display. Yep, it's the display for the board. A bit bigger than the bag that they put it in, so it's just hanging out the end. So we have a nice big, probably a 4-line or graphical display, big rotary encoder, notched, and a little reset button underneath it. Cables on the back to go to the main controller board. Nothing else on here. You do have the option of an SD card reader on here, but it's not fitted. We have that on the main board. Whether that's a pain to use or not, well, I guess we'll find out. But usually you can upload via USB as well. So if you're connected to the computer, that wouldn't really be too much of an issue. Let's just put that back in here. Now on the front, we've got some more brackets. We've got 2 thin aluminum, they're solid rods. These are probably to hold the heated bed. Yeah, so we'll put those down here. We have a pack of 2 lead screws and 1, 2, 3, 4 linear rods. They look like they're 8 millimeters. So these are 8 millimeter linear rods. So they're the same size as I'm using for the build from scratch 3D printer that I started the video of a little while ago. A lot more now aluminum extrusions. We have 20 by 20s this time, still linear rails. These ones have all been pre-drilled with holes through for assembly. Now what you'll see, I'm going to be doing a complete Core XY printer build from scratch as well at some point, and for that I'll be using the standard T extrusion angle brackets and things for assembling this. What they've done to keep the part count down and probably cost is they've pre-drilled a lot of these pieces so that you can just assemble them together using threads on the end of the linear the rails and screwing right through to assemble this. So we'll see what that looks like. Again, full of debris, so we're going to have to blow all that out. And we've got number of different sizes here again. So 1, 2, 3, 4 that are 18 inches long. Some more here. One that is 19 inches long. And the remaining ones look like they are 21 inches long. Yeah, 21 inches long. So we have a number of different parts of different sizes. So we're going to have to use some figuring out in the instructions. We'll get that out in a moment to verify what or where all these pieces go to. So let me just take out these aluminum extrusions to the garage, and I'm going to get them all blown out and take the protective covers off, and we'll get to start assembling. I'll pull up the manual on a computer, and we'll get that included, and we'll keep it in the corner of the video or something, and we'll start building this. I will fast forward on a lot of parts of the build, and I'll stop and make a detailed exam or provide fixed high-resolution photos for any aspects that need clarification as we go. Be right back after I've cleaned up and taken all the protective covering off of all these parts.